Hi, welcome back. I am Wasim. Today I will solve problem 14 from chapter 4. The statement of the problem is write down the component form of the differential equations of motion of a projectile if the A resistance is proportional to the square of the speed. So it is given in the problem that the A resistance is proportional to the square of speed. It means the speed of the projectile is very high. If the speed is low, then air resistance, it is very common, the air resistance grows linearly with the speed. But in this case, the air resistance is proportional to the square of the speed. Are the equations separated? Show that the x component of the velocity is given by, so this is the x component of velocity. We have to show this. Yeah, this one. So we have to show this x component of the velocity. So in this equation, this s is the distance of the projectile. The projectile has traveled along the path of motion, and this gamma, it is equal to c2 over m. I suppose this is the velocity vector. This is the velocity vector. Its magnitude is v, and it makes an angle theta with the z-axis. So this is the z-axis, and it makes an angle theta, and its projection. So this is its projection. So its projection on the xy plane makes an angle phi. So this is the phi with the x-axis. Then the x component of the velocity is given by Vx is equal to v cos of phi sine of theta. So this is the x component of the velocity. If the force of the air resistance is F, the speed of the projectile is v, and the proportionality constant is minus c2, then A resistance should be equal to minus c2v square. So this is actually mentioned in the problem that A resistance grows with the square of the velocity. The x component of the velocity should be equal to f cos of phi sine of theta. As mentioned in the problem, s is the distance the projectile has traveled. So in this case, the velocity v should be equal to partial s over partial t. So as mentioned in the previous slide, A resistance is equal to minus c2v square. So because in three dimensional case, the equation should be like f is equal to minus c2 into vx square plus vy square plus vz square. Thus the differential equation of motion are not separable. So from equation 2, so this was the equation 2. This is the x component of the force. Fx is equal to f cos of phi sine of theta, and it is also given f is equal to minus c2 v square. So we here the x component of velocity with respect to this equation, it is x component of force, fx is equal to minus c2 v square cos of phi sine theta. So here we will split this equation. We will split it because we know that the x component of the velocity is equal to, this is the x component of the velocity, it is equal to v cos of phi sine of theta. So so we will simplify this equation into f of x minus c2 v dot vx. So this is equation 3. As we know that f is equal to ma, so only in one dimension fx is equal to max. So in this case, if we put this value in equation 3 becomes max is equal to minus c2 v dot vx. So here we will just simplify it. Acceleration is equal to dvex over dt, rate of change of velocity. So m dvx over dt is equal to minus c2 v dot vx. So as it is mentioned in the previous slide that v is equal to partial s over partial t. Sorry. So m dvx over dt is equal to minus c2 d partial, actually this is partial s over partial t dot vx. So this partial s over partial t, it is actually v, this one. So with a more simplification we can write the previous equation in this form. M partial vx is equal to minus c2 partial s dot vx. So we will divide partial vx with partial s, with vx here. This is the vx. So m partial vx over vx is equal to minus c. So this is c2, not cs. Yes. So mvx over m partial vx over vx is equal to minus c2 partial s. So this m is we will take this into right hand side, so this is the more simplified equation. This is equation 4 and this is c2 not cs. So as given in the problem, the gamma is equal to c2 over m. So in this case equation 4 becomes, because this term c2 over m, it is equal to gamma. So this equation 4 becomes partial vx over vx is equal to minus gamma partial s. So we will integrate this equation to get our results. So partial integrating partial vx over v is equal to minus gamma partial s. So after integration we will get log of vx minus log of vx naught equal to minus gamma s. We can write this equation into this form: log of vx over vx naught, which is equal to minus gamma s. And if we remove the log, the right hand side there will be exponent. So vx is equal to vx naught, this is vx, and this vx naught is on the right side, is on the right side, and because we have removed the log, so this is in the exponent form, e minus gamma s. So this is what we have to show. So we have proved that the x component of velocity is equal to x naught dot e minus gamma s. Thank you.